Hey guys, welcome to Linux Visually. My name is Safin, and today we're going to be going over PAM, or Pluggable Authentication Modules on Linux. Now, before we get into any of the real technical stuff, I kind of want to start with this. Actually, it's a brief clip of Mission Impossible. You probably have watched this before, but I'm just going to run the clip, and we'll talk a little bit about how this really relates to Linux security. Cool. So what we just saw was a video of these three agents who are trying to bypass some security measures uh, in a highly protected environment that's likely storing some very confidential data that is not meant to be accessed by just about anyone. Now, let's pretend that you're the manager of such a company. Oops. Let's pretend that you're a manager of such a company, and you need to hire a few security teams to lock up some different rooms. Now, in this hypothetical scenario, you have three departments, for example. You might have a main hall for your employees to gather. You might have an admin room where only some administrators can access some confidential information, and an SSH room where you can access this hidden service called SSH that might be used to communicate with other agents across the organization. Now, similar to the clip we just played, all three of these different rooms need to have security measures implemented for all of them. But if I was to go about hiring independent security teams for each and every single level of security for each room, obviously that would be kind of a mess because I'd have to communicate with all these different providers for security teams, maybe hire a few workers that know how to operate a fingerprint endpoint or operate a, I don't know, PIN endpoint where you could just type in numbers. You're going to need a lot of different operators for each of these rooms. And it's going to get really, really confusing if you just have a bunch of different security teams sprawled across your organization. Now, an ideal solution would be a managing organization, like a security company that you could hire, that could provide all these different teams for you exactly when you need them. So if you were to hire for example, team that could take care of fingerprint authentication from this organization, they could on demand just give you that access to the team. You can create a building for them, and they'll have a few workers that'll be able to operate it for you. You might be able to tell the organization that, hey, for all my fingerprint teams, please make sure that everyone uses their right thumb in the detection. And the organization would enforce that across all teams, across all your different buildings that use the fingerprint team. And there's obviously many benefits to having this central organization because you can hire multiple teams from one room. For example, in the case of the admin room, you might want a fingerprint team and a two-factor authentication team. And if you haven't heard of it already, two-factor authentication is when you type in some information like a password on a website and it asks you to confirm on your phone. So all these three different teams that require some operators to ensure that the humans are kind of doing their thing, like entering the PIN or entering their fingerprint, can all be managed by a central organization. And one benefit, like I said, would be to stack these different teams. So like in the video, you had to go to three levels of security. There was a PIN, there was a fingerprint, and a gate analysis. And those need to be implemented in order. They need to be successive, meaning one after another. And obviously, it takes a lot of coordination to do that. But with the help of a managing organization, I could hire multiple security teams for one room and just stick them in whatever order I want, and that would be really easy for me. Now, let's take this analogy back over to the Linux operating system. So the managing organization, the managing organization for the Linux operating system is called PAM. And PAM sort of manages a lot of different security modules that can be used to determine whether a user is really who they say they are. Now, I'd encourage you to just pause the video here and open up the Linux virtual machine attached to this video. There should be a link in the description, or if not, it'll be elsewhere for you to find. So I'd encourage you to open up a clean Ubuntu image and just hop over to the /etc/pam.d directory as I have done here in my screenshot. So just pause the video, and once you've done that, you can unpause and I'll go over kind of what you're looking at. So hopefully you've got your image ready, and just run the ls-l command to list all the files in the directory in a list format with some extra information about maybe who owns it or what was last modified. But in this directory, we can see a bunch of files. Now, these files are sort of what we can think of as the different rooms in our security organization. They define shared behavior for each of these different rooms. Now, a lot of these are very specific to applications running on your system, but the main ones you'll be taking a look at are common auth, account, password, and session. These are the ones that are kind of shared between and amongst rooms, and it's sort of like what you tell your large security provider, hey, I usually want all my fingerprint teams to ensure that users are using their right fingerprint. And there might be an exception for one room where you want them to use left, and you would configure that for that specific room. But these common dash whatever the name is, happens to be account, auth, password, or session, all four of these files actually represent the common configuration that'll usually be applied to just about everything that falls under the category that it sort of defines the behavior for. Now, like it says here, PAM is a centralized way for applications to authenticate their users. And authentication, really what that is making sure a user is really who they say they are. Now, just like in our fake security organization that I just discussed, PAM can use libraries to offer modular configurable support for just about anything. And really what I mean by that is you can add, for example, in the case of our security organization, you can add multiple different security teams, mix and match them, move them around as you wish for all these different rooms, all these different PAM files that contain information and instructions on what to do when we ask it to authenticate. Now, for the common password, for example, file, this file will run through some instructions that we need to go through every time we change the user's password. So let's just open up that file real quick. If you just open up etc/pam.d common password, it'll look something like this. I've just blurred out all of the comments, meaning all the lines that start with a hashtag. They're actually ignored. They're just meant for humans to kind of make sure they understand what's going on in here. And speaking of which, if you ever do decide to configure PAM, I'd encourage that you do write your own comments so you know sort of what's going on, and if you have to change something, it'll be really easy to change it. Now, let's look at this file real quick. So you see here this giant arrow pointing straight down. And what that's meant to indicate is very similar to our managing organization in the previous few slides. You can have successive security teams, or in PAM that would be security modules, that implement behavior, and that could be used one after another. Now, in the case of our PAM module, we see one says some password requisite, PW quality, Unix, SSS, deny, permit. We're seeing all these different weird names that are being run one after another. Now, the basic idea of this file is that each of these lines specifies an action that'll be taken by your program that's trying to authenticate or identify a user. And it'll perform those actions in a sequential order, meaning it'll happen one after another in this specific order. Now, you see these four kind of fields in the file. These fields, what I'm saying is, each sort of line that has spaces separating different information. See password right here, and then we see a large space, then requisite, and then a large space, PAM PW quality, and then large space, and then retry. So generally on Linux config files or on Linux files in general, you'll notice that a lot of things are sort of formatted this way, where there's spaces or tabs sort of in between different, it looks like a table with multiple columns. That's sort of what it looks like. And each of these different cells are referred to as fields. Now, there's actually 4 different fields. You'll see that for all of these different lines. And all 4 of these fields have distinct meanings. So for the first field, you see all of them are password. And the reason for that is because we're in the etc.pam.d common password file, meaning that every single line will sort of function in order to do something with a newly changed or changing password. And there's actually 4 types of these. There's account, auth, password, and session. I'll talk about them in just a sec, but those are the 4 different values for the first field. Let's go and break down this first line in the config file. So if you just open up your common password, you should see something like this, if not exactly the same. Really, what this line is saying is I want to make sure that the user who's entering a new password is doing so in a quality manner, meaning that their password is good and not just the letter A. So just like in our managing organization, you might have different steps or different modules, meaning different security teams that can enforce certain behavior for new people entering the building. The PW quality module enforces that a user chooses a secure password when they're changing their password. Now, the main column you should be looking at is the third column. Now, this column defines what module will actually be performing the action. In this case, it's PAM underscore PW quality, which is short for password quality. PW password, that's sort of where that comes from. Now, PW quality, and there's a lot of different modules as you saw in this in this file. You can look at any file in this directory, in the etc.pam.d directory, and the third field will have a bunch of different modules, and each of these different modules represents a different security quote-unquote team that has some certain actions it wants to perform within the current PAM stack. And when I refer to PAM stack, I really mean the kind of list of security teams, or in this case modules, that are being executed for the program that's requesting to authenticate a user using PAM. Now, the PW quality, like I said, that could be anything from even Kerberos authentication, which is another authentication mechanism. This PW quality happens to be for password, so Kerberos would actually fall under the auth category. But PW quality, like I said, there's Unix, which is the traditional Unix sort of authentication mechanism. In this case, it's used for password changing. SSS, there's a bunch of these different modules. That's just defining what it is going to do. Now, the requisite sort of second column right here defines the behavior to do based on what the module outputs. Now, the module is sort of like a function in math. It runs some code on a defined input and gives you an output back. If you know the function f of x is equal to x plus 2, that's a function in math where if you give it an input, then it'll give you back an output. And modules work the exact same way. In this case, the input is implicit, meaning the input is not shown necessarily to us in this PAM stack, but really what it's being given is the password, because how else is it going to determine the quality of the password without the password itself? So it's being given a password, and it's going to tell us, is this password good or is it not? I mean, there's only 2 possible values for the output of every module. It can be either a success or it can be a failure. And it might have some message associated with that failure, or it might have some message associated with success. And really, what this requisite or second field, and it can be, there's actually 4 different things what it could be. It could be requisite, required, optional, and I believe there's one more that we'll go over just in one slide. It would be sufficient, but those 4 are sort of the different values for the field that is in the second column. And that defines, like I said, the behavior of the stack, meaning the behavior of the entire series of modules based on the output of this current module. Now, finally, let's talk about the password just briefly. The password sort of describes the purpose of the entire line. Like I said, in this case, it would be to do some action on a user's changed password and check, in this case, it's check the quality of it. Now, finally, the last column it describes the implementation of the module. In this case, it means the retry equals 3 refers to the amount of times that a user could enter a password without the program failing. Meaning, if the program rejects a password, if the module rejects a password, then the user has 3 more chances to come up with a better one before it just fails out of the program completely. And really, this field can have so many different arguments, because think about it. If you were to configure a module for determining whether a password is secure or not, there's so many different ways you could do that. You could check whether it's long enough, whether it has dictionary words, whether it has diverse range of characters. There's a bunch of different ways you could do that, and that's what this fourth field sort of looks like. It's really just all the different ways that you can customize this module, whether that be retry or there's arguments such as min len. I'll sort of go over them on the last slide, but there's so many different, these are called arguments in the fourth field to the module that tell the module how exactly it should be executed. And this is super important in the context of securing a Linux system, because there's so many different ways you can customize this to make it up to certain standards. Now, just briefly, we'll go over the second column field that we talked about, which is sort of the behavior of the entire stack based on the success code of the module. Now, like I said, there's 4 different kind of outputs that can have. The first one would be, in this case, what this diagram really here represents is a sample PAM stack where the first line is required, the second one is required, third is requisite, etc. The actual module and the first field and the arguments they're all omitted in this case, but really what we want to look at is just the action to be taken based on the success code of the module. Now, required means if that module fails, we'll just run through the rest of the steps, but we're going to eventually fail the module. So technically, required ends up failing it, but it'll still go through everything else until it fails. Now, requisite means if we encounter a failure, then we fail out of the stack completely, meaning we don't even go on to the rest of the stack and execute the rest of those modules. It's like if you went to the this is what you would most commonly see in those spy movies. If you failed at any section of those security measures, you'd be out of there immediately. They wouldn't even let you go to the next room or next security team to kind of perform that authentication, because each step is requisite to the success of the program. So if any required or requisite module fails, basically your entire stack will fail no matter what. Now, it's a little bit different for optional and sufficient. Optional is just what it sounds like. It doesn't even matter what the result is. It just gets run, and even if it fails, it's whatever. Now, some use cases for optional could be logging. It could be used to check, for example, what user might have logged in at a certain time. But then again, there could also be malicious purposes. Imagine if someone put an optional line in your etc pam.d common password file that just printed the password to some system log. That would obviously be a huge vulnerability on your system, because it would be kind of going on behind the scenes and you wouldn't really see it happening, but it could possibly log every new changed password attempt, which is really detrimental to the security of your system. Obviously, who wants passwords lying around on their system to authenticated users? Now, finally, the requisite flag. Requisite means if a module, if it's, I'm talking about sufficient. Sorry, I was referring to sufficient. Sufficient means that every time a module fails, if it's sufficient, and all the above required modules have already succeeded, then it's fine. We can simply continue on with the program. However, if sufficient fails and the required modules above it have not succeeded, then it may possibly lead to an error code, because, like I said, required means that the entire stack will fail out. If we look at this first column, this required failed, it still went on to the rest of them, and it ended up running the sufficient check. But because the above required check failed, the program just fails completely. So regardless of the sufficient status, it still fails out if the requisite is a failure. And if this final column is true, because even though our sufficient failed, the rest of our required modules were succeeded. We didn't end up exiting the program, so we're good to go for the rest of the program. So hopefully that gives you a good overview of what you should sort of be looking out for. one thing that I would like to kind of demo real quick is actually the use of what I was just talking about, which was changing a password. I've just got my VM with me right here. I'm going to hop over to it and open it up. And while that's running, I'll kind of go over some of the different arguments you can pass to the module in common password. Now, head over to my virtual machine. Talk about that in just a minute. I just want to get this open and show you what I was kind of talking about regarding the password complexity. So if I run the passwd command, I can change the password for any user. I'm just going to go ahead and change the password for cpadmin, but say I wanted to change it to the letter A. This would say bad password, the password is a palindrome. How does it know that? Well, let's check it out. If we hop over to, here, I'm just going to exit this out. If we hop over to etc pam.d, and we hit ls, type ls, ls, there we go. And we'll see a bunch of these different files here. We'll see one of them is actually called passwd, and that's the name of the command we just ran. Now, if we just print this file using the cat command, cat passwd, we'll see some comments that get ignored, and we'll see this @include common-password. Now, common-password is the file we were just talking about. Common-password contains instructions on what modules to execute when we're changing a password. And this @include, just basically what it does is it pastes all of the content of common password into this file as PAM interprets it. So as PAM hits this line, it'll just say, okay, cool, we're going to hop over to common password, go through all those steps, and then move on. But since there's nothing else in this file, all we're doing is looking at common password. And of course, common-password, we'll see in the common password that there is a line referring to password quality. And the password quality module is enforcing that by default, no passwords should be palindromes. So that should be sort of kind of connecting the dots for you what's going on here. The passwd command is executing the passwd file in the pam.d directory, which in turn is including common password, running through each step, and because this is requisite, we immediately fail out of the module if it fails. So that sort of explains the connection between any service and the actual PAM configuration file. Now, one thing I would like you to do actually, follow along real quick, is if you were to apt install OpenSSH-server, and this is something that we'll work with a little bit in the future, but you just go ahead and install this package real quick. You'll notice that a new file has actually popped up. I'm going to run ls-l. You'll see a new file called sshd. Now, sshd is actually the name of the service which is running on our system that corresponds to this new OpenSSH server that we just installed. And really what it does is it defines behavior. OpenSSH, just a brief summary. All it does is it allows you to sort of connect to other remote computers over the internet in a secure way. It must perform authentication though. So in order to log into a user on a different computer, you got to enter their password. And this SSHD file defines the behavior for how SSHD should act, or how PAM should act when SSHD asks it to authenticate a user. So in this file, we'll see a bunch of different stuff. The first line you should notice is common auth. So this one includes, it pastes all the content of common auth into this file, meaning that everything in this common auth file gets included and run. So this would be pamunix.so, and there's a bunch of these different modules that it runs through. So that's sort of how services relate to PAM. It gets installed as a file in this etc-pam.d directory, and it automatically corresponds to whenever PAM asks for authentication mechanism, it heads over to whenever SSH asks for an authentication mechanism, it heads over to PAM, and PAM will take care of it using this module configuration. And that's really cool because it provides, like I said, a centralized way to manage all of our security infrastructure. So that's awesome. Now, let's head back over to the slides real quick. Now, the last thing I want to go over is sort of how you can take this information and add it to your own cybersecurity knowledge. Now, I might have thrown out a few words like arguments and palindromes and all these different things that you can use to check, for example, password quality. One command I would really encourage you to run is the man command. Now, man displays a manual page with some information about every single module that exists on your system. And all you got to do is type man and then the name of the module, in this case PAM_PW quality. I've also sort of linked it here in the presentation with a link to an online version of it if you're not able to access it, but everyone should be able to open it from their terminal. And this is sort of what it looks like here on the left. You'll see it has a name, synopsis, description, and if you scroll down, there'll be some information on all the different possible arguments you can give PW quality to configure it exactly how you want. Now, if your security organization requires everyone to have a 50-character password, you can specify that. You can specify just about anything. But remember that security is always or practical security is always a trade-off between, real life and theoretical security. You can't have people remember 50-character passwords. That's not going to make sense. So how do you decide on these different arbitrary arguments that you can specify for all these different modules? Now, thankfully, there have been some amazing resources created by the US government and an independent company called CIS. So DISA STIG is the government-related one, and CIS Benchmarks is an independent company. And these two organizations have provided baselines for what you should configure for all of these different values and possible arguments for PAM modules. And if you just look up, for example, PAM_Unix.so in either of these resources, you can find tons and tons of arguments that you could possibly apply in order to further harden your system. Some arguments that I would recommend you look into, especially for PW quality, are retry, difoc, minlen, and star credit, meaning everything that ends in credit, because retry means the number of password retries, difoc is different character classes, minlen refers to minimum password length, and finally credit can refer to the sort of variability of all the different types of characters in your password. And all four of these are really good places to start when it comes to sort of baselining what your arguments should look like. Finally, the modules that I highly recommend you look into and figure out the right places for, because obviously some modules might go in common auth, whereas some go in common password. So you kind of got to play around with where they actually go and do some research on it, because they have very specific places. These modules, PW quality, history, Unix, failover, and delay, are some of the sort of most popular and best maintained out there when it comes to locking down your system. So again, I'd highly recommend you look into these for your own security purposes. One thing I just want to leave you with a final reminder is that the Linux PAM is a very finicky sort of tool. Just like if you have a large organization that you're working with and you might make a small screw up in payments, for example, they might get really mad at you and sort of shut the whole business down. And it works pretty similarly for PAM. If you mess up a single configuration, you might as well be locked out of your system completely, and that could lead to really detrimental consequences, especially in an environment where you're in a competition or you're in the real world and you really need access to that system to bring your company some profit. So what I would recommend is for you guys to thoroughly test each and every single PAM configuration that you add one by one by restarting the service that depends on it, whether that's your entire computer or SSH, and trying to do that authentication step again, entering your password, making sure you don't get an error. And if you do try to research it and debug it using the Linux kernel sort of messages, that will pop up when they do happen. So just be aware that it is a little bit difficult to get these exactly right, but with some research using these two resources and your own testing, you can really perfect it and get it down to exactly what you want. Please let me know if you guys have any questions in the comments. I'd really appreciate your feedback on this. And yeah, hopefully that made sense to you guys. Hopefully you learned a lot. And yeah, thank you very much.